All right, so homework problem, lesson 5, inclines and pulley system. A block is projected up a frictionless incline plane with initial speed of 3.5 meters per second. So it's sort of like it was shoved up. Once it's shoved up, it lets go basically. It's not like they're giving a push as in constant force upwards. They just like give it an initial velocity, and then eventually it's going to slow down, slow down, slow down, stops, and then slide back down again. Okay? So the angle of incline is 32 degrees. How far up along the incline of the plane does it go? Okay? And B, how long does it take to get there? And what is the speed when it gets back to the bottom? So there are a lot of things they're asking here, but if we break them up, it's not as bad as you think. So here, so since this thing is moving in this direction, your acceleration is going to be in the opposite direction because it's going to slow down. That acceleration is caused by FGX. So if I were to do a free body diagram on this, okay, so here we go. Here's my FG. This FG will have, right, FGY and FGX. So this is the FGY, and this will have FGX. Okay. This angle here is 32 degrees. And so is this. This angle is also 32 degrees. So what's going to slow this thing down? It's the FGX that's going to slow it down. Okay? So we have to think about this being the x-axis, this being the y-axis now, and we have to rotate this whole system so that now that we have x and y as such. Okay? Since the direction of motion is up the incline, for now, as this thing is moving up, I'm going to consider this direction to be the positive x. Okay? So let's think about finding the acceleration that's acting on this block. So sum of all forces in the x direction is equal to max. Okay? And sum of all forces in the x direction, there's only one force acting on this in the x direction, and that is the FGX. So if I set them up equal to each other, max is equal to, right, FGX is going to be negative because it's going in the opposite direction. It was pointing in the opposite direction of motion, which is going up. And we're going to consider the direction of motion to be positive. So negative FGX is what we have. Okay? Therefore, my FGX is really FG times sine of 32 degrees. Okay? Therefore, my acceleration, well, max is equal to negative, right, FG sine of 32 degrees. Well, FG is really nothing more than mg, right? So if I were to look at this, my MAX is equal to negative mg sine of 32. Notice what happens to my mass. My mass gets canceled out. Okay? So my a sub x is equal to negative 9.8 times sine of 32 degrees. So my a sub x is equal to, I get negative 5.2 meters per second squared. Now, once you have that acceleration, now you can actually solve for part A. We have acceleration. We know the initial velocity v naught, vi, is equal to 3.5 meters per second, and it is positive because it's pointing in the positive x direction. We also know my final velocity at the top, when it reaches the top of the incline, is going to be 0. So that's my VF, right? And you could say this is your VI. So I have three things here, and I'm looking for my delta x. Well, that's simply the third equation, isn't it? Right? That is, I guess you could say VF squared is equal to VI squared plus 2A delta x. This is from your summer assignment, actually, from chapter 2. So 0 squared is equal to 3.5 squared plus 2 times negative 5.2 times delta x. So hopefully you should be able to calculate the delta x. If you can't, come and see me. We'll have a nice heart-to-heart talk. So that was A. Okay. What about B? How long does it take? Well, if you were to think about it, for part B, let's pick a color. For part B, okay, they want time. Well, that's pretty easy now, right? Because we know acceleration again. We know initial velocity in the x direction, which is 3.5. We know the final velocity is 0. Equation number 1, right? So VF is equal to VI plus AT. 0 is equal to 3.5 minus 5.2 T. So T is equal to 0.674 seconds. All right. What about part C? What is its speed when it gets back to the bottom? Well, symmetrically, since there's no friction, it's going to go up, stop, and only force that's going to make it accelerate is the FGX going back down. So 0 to final velocity here. So now this is the initial, which is 0 for part C, and now this is final, right? It's really not going to be that much different than what's going up this way. So it's going to probably come down at 3.5, okay? And if you want to check it out, you can, because you know you're looking for VF. You know your VI is 0, because now this is your initial, and this is your final, right? And then we know the acceleration that's going to be bringing this down. Now we're going to consider this direction to be positive, right, for part C, because this is the direction of motion, right? So we're going to consider this direction to be positive on the way down. So the acceleration is actually going to be positive 5.2 meters per second squared in this case. Are we okay with that? Okay. And we also know the delta x because we calculated it. The distance that it's going to travel is going to be 1.2 meters. I mean, there are plenty of other ways to do this, but you could have used equation 1 too. Okay. So if you use this, equation 3, right? So Vf squared is equal to Vi squared plus 2a delta x. So Vf squared is equal to Vi, which is 0 squared plus 2 times 5.2 times 1.2. So my Vf is equal to plus or minus, because you have to take a square root of a number, right? 3.5 meters per second. Now, since they want speed, it doesn't really matter what direction it is, right? It is just going to be simply 3.5 meters per second. Okay? I mean, you could have also used equation 1. If you use equation 1, that works just as well, right? You could have used Vf is equal to Vi plus At. And since you know it takes this many seconds to go up, it's going to take that many seconds to come back down. And that's because there's only one force, Gf. Fgx is the only one that's working on it. Things change when you have friction. Later on, we're going to learn with friction, friction is going to actually act down this way on the way up. So they're going to actually have two forces acting down in that negative direction on the way up. But guess what? On the way down, look what happens. Your Fg will still act down the incline, but now your friction is going to actually act up the incline. You see the difference? So on the way up, you're going to have a greater negative acceleration. Here, your acceleration is going to be the difference of Fg sine theta, right? G sine theta minus the frictional force. So you're going to have a smaller magnitude in friction on the way down. So we'll talk about that in the next chapter, actually. All right. Any questions? All right. We'll move on. All right. Next. I lost. Hold on. I lost these guys.